Okay, I think we're ready to get started here. We've given folks a few minutes past the time to start. Kevin, Andre, you guys there with me?
Yep.
Yeah. Okay, great. All right. Thank you, everyone, for joining us today. Just got a quick little presentation here. I'm Lee, and I've got a couple seasoned veterans from the Quebec office joining me to do the presentation portion today with Kevin McLean and Andre Lapointe. Thank you, Kevin and Andre, for putting this together. A little bit of an agenda. I'm just going to do a quick introduction on the GoToWebinar itself, and basically then we'll just jump into the all the different options that are available to show off: Simco Verify, Simcoedit, Milturn Lite, machine simulation / Moduleworks, and then machine simulation with a post, and then IMSce. And of course, we'll do a Q&A section right at the end. Before I kind of get into the presentations, just a little bit of housekeeping here. You'll see the picture to the bottom right of the screen here. That's what the web viewer looks like. You'll see the option right here for questions on your widget. If you select that button, then what you can do is you can type your questions in down here. And what we'll do is we'll get to all the questions at the end. For those that haven't joined us in a webinar before, these webinars are recorded, so I will certainly be sending out the recording to yourselves, and then you can pass it along to any of your colleagues that maybe weren't able to join us today. And it takes a little bit to compile, but we'll likely have that out to everyone tomorrow. Before I jump into anything, a little bit of exciting news that some people may not be aware of. There is an active update promo for Mastercam. To put it in simplistic terms, the option is there for 3 years forward, 1 year back. So if you happen to have some older sims that aren't up to date, they're a couple years old, it's 3-4 versions back. So instead of paying all that catch-up fee, there's the option to do 3 year forward, 1 year back. And of course, there's other options available depending on your circumstances. If you only have a seat or two that are, say, 8-10 months that are off, we can certainly look to get you some decent pricing there. So feel free to reach out to me or your rep for further details on that if that's of any interest. As many of you know, we haven't been able to have a promo for a little while now, so I think this is pretty exciting. Okay, so just to jump into kind of what we're trying to cover here today, essentially we're just trying to highlight and explain the different simulation options that we all have available to us with Mastercam. So over here on the left, which is your NCI simulation, this is the sort of the backplot and the verification that everybody's used to that comes with Mastercam. So we will touch on that. We're going to show a few different options available for that. Then next what you have is you have a simulation with a post-processor. So those that are using the Moduleworks machine simulation, you'd be fairly familiar with this. And the idea behind this is the post-processor that you're using to generate your G-code is the same post-processor that's being used to show off the simulation. And then lastly is our G-code, true G-code simulation option. So what this is after you've posted your code out, you then take that G-code and run it through the machine simulation, so it'll show you exactly what you're going to get on the machine. And Kevin and Andre are going to show us all sort of 3 options here and dive deeper on each one of those and show you the options that are available. Okay, now to the presentation point.
I'll take the lead for me. Let me just. Are you guys seeing my screen with me at the bottom?
Yes, we can see.
We see our OBS studio screen.
Yeah, okay, let me just change my monitor. Sorry. It's going to be this one. Yeah. Now it's better, right?
Yep.
Yeah.
Okay, sorry about that. I'm going to be showing you Simco Verify and Simcoedit Pro. Essentially, you guys might be already familiar with Simcoedit. It's a free software, or a version of that software is freely available with Mastercams for editing and sending your code to the machine. But Simco you might not be aware of as a wide variety of product, and one of them is called Simco Verify. And the whole concept of Simco Verify is essentially to replace your current Verify that comes with Mastercam. I mean, not replace, but give you another way to do your verification. Let me show you an example of why you might want to be interested in Simco Verify. I have a mold here. It's a fairly large part, fairly large program. We're talking about, you know, like a lot of code needs to be processed. And if I try to launch the regular Mastercam verification tool, so I just go in there, launch the verify, and you will notice, or you might already have noticed, that on larger file with larger G-code, it might take a while to get into the proper simulation. It has to load a lot of information, and then once you're there, you're still not ready to simulate. You still need to, you know, load the entire NCI code into the verify. You can still start to do the simulation right now as it starts loading the program, but it's a bit it could be a bit clunky maybe sometimes. It's still a great tool. There's a lot of wonderful options in there, but we will get there eventually, where we're able to start the simulation. Once the code has been properly loaded, we're good to go. Maybe I just want to see the end result, so I will click, you know, end result, and it will process that code, and eventually we're going to get to a point where we get there. But you see, it's moving slowly, right? And that's the old point of using Simco Verify, is whenever you're working with a larger part, you might realize that you spend a lot of time doing your verification, and you want to drop down that simulation time. So you install Simco Verify. It comes within with its own tab, and you just click on Simco Verify the same way you would regularly click on Verify. So you click on this, it will open up another interface, just like the Mastercam Verify does. Let me just here you go. And you will notice that it's already loaded, ready to go. I can click show me the end result, and I'll be within a few seconds be able to see the entire result of my simulation. The quality of the simulation is all right, but there's a new option. This is only available in the newest version. It's called True Vision. So you see how when I zoom in, it's still, you know, it looks like more like facetized and everything. You activate True Vision, and with a fairly decent graphic card, you're gonna be able to render that within seconds. In different areas of your part, you're gonna be able to see the exact tool mark that you can expect on your part right out of the box like that. What is also nice is you can play and move through the options. It will actually bring back the material, so I can go back to the start after the first operation, after the second operation, and you see how fast and responsive is the entire software. Now, Simco Verify has all the same options you're probably used to with the Mastercam simulation. We're able to do, you know, cross section like that, and, you know, play with this. We're able to stop condition on collision, operation change, and all that stuff. We can set with colors or not, depending if you want your machining color to be different for each tool. There's also a really nice feature as well, is but I'm going to show you in a different part because I don't think there's any collision in that file. But I have a file here. I will run my Simco Verify, And without the machine simulation, because that's a different thing, without even doing the actual simulation, I can go right away into collision checking and check for my collision. And it will basically, on a file like this, which is like a multi-axis file, so there's still a lot of operation, I can double click on a specific portion, and it will actually bring me back to the exact collision. And same thing goes for this, and it will regen the stock to that point to where the collision is. So as you can see, it's really, really fast, and that's the entire point of using this simulation. Is you want to be snappy, fast, get the point within only a couple of seconds to reduce that time. You spend 30 seconds each verify to get things going, and you do that like 14, 20 times in a file, maybe 100 times per day. Well, that adds up really fast over time. So if you can reduce that time, you're eventually going to save a lot of your programming time just by using that new simulation. Now, it also comes with machine simulation, and the concept of machine simulation in Simco Verify is essentially to see the actual machine going on, right? You can build your own machine. So there's a feature available for a machine builder, so you can build your own machine. But keep in mind that this does not simulate G-code. So we're still talking about NCI. So it's really the same thing as doing a verify in Mastercam. So your post processor and your G-code will not be taken into account if you use this, but you're still going to be able to at least see the motions, right? So if I go into multi-axis toolpath and I press play, we're going to see. I think I'm going too fast for you to actually see it. And do I still have the collision on? Yeah. So let's not stop on collision. So it's just going to get there. Oh, I'm not in a multi-axis toolpath, I think. But yeah, but we can see like the machine actually moving, right? So you can validate that there's no collision involved in your programming with that. Now, that's for the Simco Verify part of the product. It also comes with Simco Verify setup options where you can actually choose to import your model, your fixture, your stock setup, and same thing. Also, you can look for different machines, right? If you have the machine simulation options, so you can simulate it on different machines, and you can also position your part properly into space. So right now, this is going to be positioned at the center of the table, but if I put some values in there, it's going to be shifted one side or the other, trying to replicate, the actual setup on the machine itself. So Simco Verify, really, I think a great product. When you compare it to Mastercam, I think it's just faster, and we're just looking at getting more efficient in every aspect of our programming. We're talking about, AI programming, automatically programming, all that stuff. But the verification is still part of the process and need to be taken into account when you talk about programming time. Now, the other portion of my presentation is going to be about Simcoedit Professional with machine simulation. So Simcoedit, we know it, it's a G-code editors. But if you have the Simcoedit Pro version, you will have access to the backplot tab where you can actually backplot most G-codes. When I say most G-code, any regular G-code, Idenine, Fennec, Mazak, Haas, and all that stuff, Siemens is going to be supported. And you can also add to that Simcoedit Pro license a machine simulation license, which will simulate your G-code with machine motions. The nice thing about this is if you decide to buy Simcoedit Pro with machine simulation, you can install Simco Verify and use it as a plugin to import all information about stock setup, tooling, and fixtures. Okay, so it's really, you don't need to have the Simco Verify license to use the run Simcoedit portion of it. You will need to have the Simco Verify options if you want to run the Verify within Mastercam. But if you just want to have a G-code simulation, you installed it as a plugin. And it used the same options as the Simco Verify setup here. So you will select your Simcoedit configuration, and this will bring up a list of machines that you have installed in your Simcoedit. And that's basically it. Let me just close because I still have it open here. Let me just close this one. So here. And you will have access to the run Simcoedit and not the start verify if you don't have the Simco Verify license. I just want to make sure it's fully clear that Simco Verify is its own product, but it uses the same plugin to use Simcoedit Pro with machine simulation. So you click Run Simcoedit. It will essentially create the G-code through your Mastercam post processor, and then open up your Simcoedit with the G-code, with the machine model, and then you will use the same engine as the Simco Verify. So it's still going to be fast, it's still going to be snappy, but you have your G-code right here, and you will be able to just basically press play and see the different machine motions as it goes through the different G-codes. So it's live. You can actually stop it and make modification to your G-code. You're gonna be able to play with stock. Do you want to see your stock, your workpiece, and everything? I can make the base visible if I want to see the entire machine or not. So you can play with all that. And again, it's the same engine, so same controls, same everything. Yeah, so let's just go through the G-code, get to a multi-axis toolpath, and as you can see, it renders the model pretty fast as well. And then you just press play and you see the full 5-axis simulation from the G-code itself. It doesn't need to be tied in with Mastercam. The only advantage of using it with Mastercam is that you can easily import your fixtures, your model, your stock setup, your tool information to this. But you can definitely use this if you just open a G-code and you use this menu here on the side to add fixture, add workpiece, add stock. You can define your stock, change your different values and everything, define your work offsets on the machine. So you can play with your work offset from the machine model and everything. So you can use it as just a basic G-code simulation, but with tied in with Mastercam, it just becomes a bit more easy. I forgot to mention something about the Simco Verify. So let me just get back in there real quick. It's the stock compare. I know a lot of people want to basically just see, are we within tolerances and everything. So once you've ran the Simco Verify, and as you can see, it's really fast. Like when you compare it to Mastercam, I'm not even started up. I click on Verify. Within a couple of seconds, I'm ready to basically click to get me to the end result. And I think within 5 to 10 seconds, I'm right there. I'm ready to see the end result. And then I can just hit compare, set my tolerance here. So let's say 3 tau with the True Vision, because I want to get more accurate values. And as you can see, you will be able to see green and red where material is remaining and where it's not. And I made a gouge in the part here. And as you can see, as you move your cursor on the part, you actually see the gouge value or the amount of gouge you're actually having in this section of the part. So yeah, and the compare is also available within the Simco here. We should have options to compare, stock compare here. So same things, as you can see, is the same interface and everything, and it will eventually render the model the same way. I'm seeing the workpiece here through the part, so this is why. And that compare range right now it's in metric, I think, so that's why it's all green for now. But yeah, So essentially, it's the same engine that comes with the Simco. Now, when you buy machine simulation with Simcoedit Pro, it comes with a preset of different controllers. It comes with all the controllers, so you don't need to buy different controllers for each of your machines. You will be able to build your own machine. Obviously, if you want, we can build your machine models for you. But one thing we have to realize is that the emulator, let's say for Haas, is predefined. So unless you have something specific on your machine, like specific macros and all that stuff, it's really fine. Like if you have a basic machine with default controllers, you can use those simulations, no problem. It's really for more complex and more advanced machines sometimes that we might need to ask Simco to create a new version of the emulator specifically for your macros on your specific machine. So most people, it's going to be all right with whatever is native in the software, but we can improve on those if it's something we actually need. Also, like one thing to note is whenever you do stuff in the Simco edit here, you can right click and you can save your setup essentially. By saving your setup means there's multiple ways to save the setup, but one way is it will actually write on top of the G-code here some information, so that when I reuse that G-code, it preloads all my information that I have defined. But you don't need to worry too much about that if you run with the application here within the Simco Verify tab. It will export automatically those STL, and it will also export a setup file. And as long as it's the same folder as your NC file, you just open the NC file, and it will populate automatically the machine model, the stock, the fixtures, and everything. So you don't need to always post from Mastercam to get that. It's saved automatically with the file. Simco Verify can also work with lathe. Right now, we are limited to one spindle, one turret lathe, 4-axis lathe, so no B-axis for now. They're working as we speak to integrate a sub spindle to get the stock transfer and all that stuff. But just to give you an example here, I have a simple 4-axis part. I can definitely still use my Simco Verify, either with machine simulation or not. And if you go with machine simulation, you will notice that I see the entire machine environment, and I can also run it just as a basic verify here, where I see my tool and use it as my verify. And again, you're going to be same responsiveness, so you can go real quick to the point. Now you can move around through the operation here and get to the end result real quick with or without the machine simulation. And same thing goes for this part. Now, if I want to simulate the G-code, I could just set it up so that I'm using, maybe Haas turning and run Simcoedit, and I'll be able to simulate the G-code with my Simcoedit and not the NCI only. Okay, so it's the same options that comes in here. So I don't have any machine model installed in my Simcoedit for late, so that's why. But we can still see that it's showing up. I just metric conversion. I have a setting to be adjusted for that. But essentially, yeah, that's what Simcoedit offers. So 2 different solutions using the same powerful simulation engine. So definitely something to keep in mind. Depending on your needs. I'm just gonna check. There were some questions, but I think they were answered. So I think I'm gonna leave it to Andre. So let me just change the presenter, and you should be up and running, Andre, for now if you want to do your presentation.
Yeah. All right. Let me share my screen, monitor 2. There we go. So you should all be seeing my Mastercam screen. So I'm gonna kick this off with the mill turn part of the simulation. So just to continue over the late package simulation. So Mastercam came up with a few years ago with a new module called mill turn, and it was essentially made to be able to simulate all machine environment with B-axis head, lathe, sub-spindle, lower turret, so that we can have a graphical synchronizer, so that we can sync those upper and lower turret and all those operations together and be able to simulate that in the Mastercam software. Now, the mill turn Lite is pretty much the same thing, although it doesn't require the purchase of the mill turn module, because it's only, as the name says, it's only a light version. So it only consists of a specific post combined with the 3D machine environment. And it is meant for a simpler machine, such as single turret, single spindle, or single turret, twin spindle. But as long as you have a need for a twin spindle, or a twin turret or a B-axis head machine, then you will be required to get the full mill turn license. But enough about those limitations. Let's jump in what is really interesting. So I have this part that I'm doing on both spindles. I have both upper and lower turret with a part transfer. So it's programmed. I just hit the post button here. It's going to jump into the code expert interface where I can synchronize my operation and decide which operation is going to be waiting for which others to be completed. And then I just hit the launch simulation here to get to the actual 3D simulation here with the whole machine in there. So keep in mind that this is still what we call NCI simulation, although it's a little bit more flexible than what we are used to with the, let's say, the default Simco Verify or the Mastercam Verify, whereas there are a few options that I can discuss a little bit later that will have an impact on the simulation itself. But just know that it's not related or linked to the post to drive the simulation itself. So there may be motion added by the post afterwards that will not be simulated itself. But still, it will give you the same similar interface that you're used to with the Mastercam Verify. You'll be able to use different view sheet, collision checking, clips or compare for all of what you need. You can get proximity alert, you can get collision as well. So you get this whole report here. You can get over travel values as well based on machine travel. And yeah, you get the whole move list here for both stream, the coordinates that are going to be into machine coordinates value. And then you also have the default move information, whereas which operation you're into. So this is really like the mill turn simulation or environment. The points that I mentioned that we have some control over that we don't in the regular late package, for example, is the approach. We can change how we want to handle the approach. Is it going to be Z first, X first, or direct? And same thing for the retract motion. So we can choose how we're going to retract from the operation and where we're going to end up. So we have different reference position we can define, and these are going to be reflected both in the code and in the simulation. But that's pretty much the only options that you can alter that will impact in the simulation, that given that it's still driven as part of the NCI simulation. So the only difference with the mill turn Lite is that usually you only have one stream of code because you only have one turret, so you don't need the syncing. So you just go through this interface to set up these options, which are similar to the MISC values, and then you launch the simulation and or you generate the final code from here. That's pretty much it. So for the mill turn, it's pretty much all we need. So now we're going to take a look at more what we call the machine simulation as part of the Moduleworks machine simulation environment. So the way it works is you all have as the default install of Mastercam a machine simulation package that you can you just select the operations you want to simulate, and then you expand this little button here that will allow you to choose whatever machine you have. There's a bunch of generic machines that you can choose. Oh, bad, wrong one. So you can choose generic machines that are in there. So I just picked one that I had already. And then from here, you choose which workpiece. You can load that from anything that is on the screen from a specific level. Same thing for fixture or stock. You can use whatever has been defined in your Mastercam stock definition. And the default setup, which, like I said, is already included within Mastercam. The only thing that is not included is if you need a custom machine to be made for you. But if you use a generic one, it's ready to use as is. You just don't use the external post, and you hit simulate. And then what's going to happen is that it's going to load the NCI into the machine simulation interface, and you'll be able to see the part. I already had one open. So you'll see the part position in your machine, and with the tool and everything, you'll get the coordinates here based on the Machine Sim origin. Get your operation, you can get a report of collisions or over travels, and you can get axis control where you can play with your machine's axis and double check where if you are in over travel by how much and so on. And then you can run your simulation. So now, given that this is an NCI driven simulation, you can see right now I have a collision, okay, between the head and the part. So to avoid that, I would require my head to be rotated by either 90 degrees or 180 degrees. And this is actually what I had programmed in my file. I'll show you that in a second. And if I just let it go a little bit further up, and I'll jump into the multi-axis here. I'll slow this down. So what happens here is it rotates and rotates and rotates and keeps winding the C-axis, even though my machine only has a limit of 270 degrees here. So all I'm going to have is a report saying, hey, there's an axis overrun here that you are going way too far for what the machine can do. And it won't give me any indication of how to solve that or anything. Whereas, like I was mentioning, I have an operation. My tool plane used here is rotated 90 degrees from my coordinate system. So this, when I run that through my post processor, will generate a rotation of 90 degrees of the head so that it avoids the collision here. So one way to simulate that would be to still use the machine simulation, but this time we're going to use it with what we call the external post. So what we're going to do, like we mentioned, is that we're going to use the same post that we use to generate our G-code to generate the file format for the simulation. So I just hit the simulate button, don't need to change anything else. And then I'm going to have the same question prompt, same miscellaneous values that I've set in my operations are going to be handled in the simulation as well. So I'm going to say, okay, 23-inch clearance above part. I'm going to get that warning about the over travel because my post is detecting that I have an over travel in my program. I'm going to say, okay, yes, I want to retract for unwind, 6 inches about right. And it's going to complete the generation of the code and then launch back my simulation interface right now. So I have my simulation interface here. I still see the coordinates based on the Machine Sim coordinates. But now if I run my simulation, I'll just run it slow here. You see the head is rotated 90 degrees compared to what we had before because it accounts for my programming specification. Okay. And when I jump into the, go to the 5-axis toolpath here. So when I go into this operation, we'll see that the head eventually needs to retract. Let's slow this down a bit. So this area has a lot more points. Okay, I'll go manually then to the position that I want. So I'm retracting. So now I'm going backward. Sorry. So I'm at the end of the rotation. So my tool retracts. Oh, my bad. Trying to go too fast here. Skipping the actual motion. So it basically unwinds the C-axis and then re-engage, and that's the purpose or the actual motion that you should see on the machine right there, because this is the retract motion that we are generated from the post. So now something else, still using the same free operation, we're going to jump into another simulation package that we have, which is called IMSce software. Okay, so the IMSce CE is through G-code simulation. Okay, so it basically uses your NC file. So what I'm going to do is I'm just going to post out my code here. So I'm going to call that this here. So I'm going to have my same prompt that I had earlier, because same post processor, just generating my NC file now. So I have my code here, so basic G code. And now what I'm going to do is I'm going to hit that IMSce button here. And basically I have to set it up like if I was doing, like if I was loading the part on the program on the machine. So I need to tell it, well, what are going to be the length, the tool length. So I need to load these information from the Mastercam file. So I can just extract those from the current machine groups. It's going to export the tool profile and the tool length. I will also need to set the origin table. So which work offset I'm going to be working with and where are they located based on my simulator's origin. So I can extract that easily from the machining 0 position I have set here. And then I can also set up my workpiece. I'm just going to pick that up on the screen, set up my stock here like that. I choose machine file I'm going to be working with, as well as the control emulator I'm going to be working with. So one of the big benefits of IMSce is that we are not tied to any generic controller. So we can basically build up any control emulator that you need, provided that we have the information to understand what the specific G codes or commands are doing to in the machine itself. And then we are going to pick up the actual NC file that we want to work with. So I say I delete that and just go back and pick my file. Then I hit the simulate button. What it's going to do now, it is going to load up the STL. It's going to make a copy of the 3D file. It's also going to, like, we don't see it right now because it's on my other monitor, but it's actually parsing or reading the actual NC file to be able to load it up into the simulation. And then the simulation screen that will come up is going to be really similar to the one we had before, given that the IMSce solution uses the same Moduleworks simulation engine. The only difference is the source where it gets the simulation information. So right now we're driving the simulation from the NC file, as opposed to having it from the NCI or from the post itself. So we see here the actual G code that we're going to be running with the coordinates that we have here. And then we can see in my program that here we have that 90-degree rotation as per my G code. And I'm going to be running my program all around here, similar to what we've done earlier. One thing that is really interesting with G-code simulation, especially with this one, what I like is that given that we need to specify all those work offset tool lengths and stuff like that, it will allow us to detect whether we've made some small programming mistakes. I'm just going to get to the point where I want to show here. And there we go. So we're reaching the second operation. Okay, so we're at the end, retracting, and then we do the operation, which is supposed to happen over here. But what happened is that in my program, in my Mastercam file, I made a mistake and I have the wrong work offset sets. And so instead of working off my G59, I'm working off my G54.1 work offset. And given that I have not set that origin in my IMSce configuration, it is going to simulate off the machine origin coordinates, which is way off base here, up in the air. Okay, so I can let it run and see that my next operation is going to be using the proper origin. So this one's going to be all right. And again, I'm going to be able to see these on the wind motion and let it go fully 5-axis and simulate that. So now if I want to fix that work offset thing, I can just go back into my NC file here, search for my G54.1, change that for my G59, save the file, and then just relaunch the simulation. So I don't need to change anything in Mastercam. Mastercam in this case is only used to launch the simulation and gather tool profile and stuff. So we don't actually need to select or pick any operation. I could have no operation selected. The only thing that it's going to take is the actual tool profile of the machine group and the 3D model that we have already selected. So simulation is going to pop in any seconds now. Go. It's going to be moving my stuff over here, and then I can now jump to second operation here, and not that far off. Simulate the motion there, but I want to go a little bit higher than that. There we go. So we can see my second operation now is being done to the proper location, given that I'm using the proper work offset now. So get my side machine properly. Let me see, make sure I haven't forget anything. I think that's pretty much it. Yeah, so we can simulate pretty much anything. Like we mentioned earlier, the Simco Verify or Simco Machine Sim currently only supports single turret, single spindle. They're working to implement second spindle pretty soon. As of IMS, we currently support B-axis head or single lathe turret, twin spindle with part transfer, lower turret, syncing option is on their way. They're working on it right now. So we are hoping to get something about this pretty soon. But yeah, that's pretty much where we at right now. Not sure, Kevin or Lee, do you think I've missed something? Is there anything else you want to add, or if there's any question?
There was no question in the chat about your presentation.
Good. Great. There. Anything else you wanted to add, Lee, or?
Yeah, I guess what just obviously there's certainly a fair amount of options for everybody, which is great. As a Mastercam user, depending on your requirements, your needs, there certainly is a product out there beyond obviously what we can do inside of Mastercam with the standard backlot and the verify. And then, of course, the generic machine simulation that kind of comes preloaded default within Mastercam. So really, I hope we were able to kind of cover everything for everybody. And again, depending on your needs, depending on your requirements, depending on your application, there certainly is some options out there for everybody. So we're about to wrap it up. Just wanted to remind everybody of the question option. So if you look for the question mark within your widget, please click that button. Please type in your questions, and we're certainly sit here and go through them, and we can double back on any of the Simco ones that we saw from Kevin. Please ask away. Otherwise, to the end here.
Sorry, Lee.
Yeah,
one thing that I may add that we haven't talked yet, sometimes people are interested in knowing that those two simulation options with G-code simulation, whether it's the Simcoedit with the backlot or the verify or the IMSce, that they are able to simulate macro commands. So if you have some specific macro or sub-programs that you're running, it all supports that. So if you run program with a couple of sub-programs into it, they will jump back and forth or from or to the program and execute that in the simulation without any issue. And if you're using variables to control the behavior, some of those macro or some of those motion, just make sure that the initial values are set somewhere in the program when you start the simulation, because obviously simulator will not know offhand what the values are set on the machine by the operator, for example, and then it will simulate or work properly.
Perfect. I just wanted to take the screen back here. Good. I just wanted to, some people may or may not be aware of our new public text space that we have. So I've got a QR code on the screen. If you happen to have your phone handy, please take a picture of that and it will take you to our public text space. I'll leave that up here for a few moments. My contact.
There's a few questions coming in, so I'm answering one.
Yeah. If you need to screen share, Andre, to answer the question.
Well, I guess I can screen share for at least one of the solution. Let me just take that back.
Perfect.
Screen 2. There we go. So to answer Justin's question about how to position the fixture and parts properly in the simulation, for example, in the IMSce packages, we have this, what we call the machining 0, where you put the offset from the current Mastercam work offset origin that you're working into to the actual simulation origin. So in my case, the machine simulation origin is at the machine origin, so I need to set a -X, -Y, and -Z value to position this on my part, on my table. And then by the way the simulator has been built, this will give me the pretty much the exact values that I'm gonna have into my work offset table on the control to be able to run that program without any over travel or anything that I would see in my simulation itself. So this is for the IMSce, and if you're looking at the machine simulation, we have pretty much the same thing. Again, it's relative to the simulator's origin and how the way it's been built. So some of them are built with the origin on the table, some are built with the origin on machine origin. It's mostly on customer's preference. So you just put a translation value based on that origin to where to import the 3D and the program itself. As for the second question for Stephen, none of these simulation packages are run from the cloud, so it's all offline. It's installed on your computer, and it's running off your local information. So there's no cloud connection at all about that.
The only restriction I would say maybe for Simco, you might need to do an online activation, but there's a way to activate for offline computers. The same way that Mastercam license would work when you're working offline and you want to activate your license.
Yeah, just for the license, but not for running the product itself on a day-to-day basis. Great. Any other question? We don't see much more in the chat. All seems to be clear. Was there another slide to your presentation, Leach? You want to take back control, or it's all good?
No, that's okay. I can just go back here just to show the QR code again if anybody didn't have an opportunity. But if we don't have any questions, any further questions, we'll be wrapping it up here shortly. Appreciate everybody joining us today, taking the time to go through these presentations. I appreciate everything, Kevin and Andre, for the presentations. I think you guys covered it really well.
There's a question in the chat, Lee. It is recorded. It will be uploaded with on our YouTube. We're probably gonna make an article in our next newsletter. But like if you require the link earlier, just reach out to your sales rep, and once the link is available, we'll be able to send.
Yeah, I actually send out the link to everybody who's registered, whether, so people who registered or attended, it doesn't matter. Everyone will get that link once it's ready. It takes a little bit to compile the video and edit the beginning and the end, but we'll have it out. You should have it in your inbox in a day or two. And it's a YouTube link, so you feel free to share it with your colleagues as well. Okay, I think if we don't have any further questions, we can wrap it up. Thanks again, everyone, for joining us. Thanks again, Andre and Kevin.
Welcome.
Thanks.
Have a great. Oh, hang on. We have a question.
Yeah, few of them come in. Okay, few thank yous, but there's one question from Ryan. I joined late in Mastercam simulation. This button to use external post. What is this for? And this. Yeah. So Ryan, to answer your question, the external post is used only if you have a post processor tied to the machine simulation model that you have created. And what it does is that it uses the same post that you use for your G-code to generate the information for the simulation. So it's not reading the simulation from the G-code, but the same post will generate the information. So if you have a MISC value to control your tilt option, for example, on your table or on your head, it's going to account for that. Whereas if you don't use the external post, it's just going to use the default solution in the simulation as is. Okay, so I think that that's pretty much it. You're welcome. I think we have answered everybody. Yep.
Yeah, it's just making sure there wasn't.
Yeah, no worries.
A few more filtering in here, but yes, I believe we're covered here now for all the questions.
Yeah. Anyway, if there's any more questions, they know how to reach us, right?
Yeah, absolutely. Okay, great. Thank you, everybody. Have a great afternoon.